Hi viewers, I wholeheartedly welcome you to this particular session. In this session, we are going to explore the fourth group separation table. So what are fourth group cations? As per the present aptitude syllabus, we have nickel plus 2, Zn plus 2 and Mn plus 2 cations in fourth group. So this is the solution that is supplied to me by the lab attendant. I need to explore the fourth group cations present in this. For that, what should I do? I need to add fourth group reagent to this solution. If I get a precipitate, that implies fourth group cations are present. Now, what is fourth group reagent? Fourth group reagent is nothing but ammonium chloride solid in excess, ammonia solution. I told you already in the laboratory, ammonia is also represented as ammonium hydroxide. Now, to that particular solution, I need to pass H2S. So this is the fourth group reagent. So come again, what is fourth group reagent? Ammonium chloride solid in excess, ammonia solution, and then H2S gas. Okay, so let us see whether we get a precipitate by adding fourth group reagent to this solution that is supplied to me by the lab attendant for fourth group analysis. So to this solution that is supplied to me by the lab attendant, I am adding ammonium chloride excess because I need to prepare a saturated solution. So I have to add ammonium chloride in excess. So I am adding ammonium chloride. I am checking whether a saturated solution is obtained or not. So I did not get a saturated solution, therefore I need to add some more ammonium chloride. I am adding. Addition of ammonium chloride to the solution is an endothermic process. That is the reason why if you touch this particular test tube, it becomes very cool. Okay, so I have added enough amount of ammonium chloride. You could see little amount of ammonium chloride left at the bottom of this particular test tube, right? So I got a saturated solution of ammonium chloride. Now I need to add ammonia. So in the laboratory, ammonia and ammonium hydroxide, they are one and the same. So I am going to add little amount of ammonium hydroxide to the solution to which already ammonium chloride is added. So I am adding ammonium hydroxide solution. Okay, now I have to pass H2S gas through this particular solution. I have to pass H2S gas. Did I get a precipitate? I did not get any precipitate. Of course, you might be observing a small change in color here, but I did not get any precipitate, which implies I do not contain third group cations in this. Because what is third group reagent? Ammonium chloride solid and ammonia is a third group reagent. If I add third group reagent, if I get a precipitate, it implies third group cations are present. But I have added third group reagent here, I did not get any precipitate, implies third group cations are absent. Of course, obviously third group cations will be absent because this is a solution that is supplied to me by the lab attendant for fourth group analysis. So let me pass H2S gas through this. Until now, what did I do? I have taken the fourth group solution that is supplied to me by the lab attendant. Then I have added ammonium chloride excess, ammonia. Now I have to pass H2S gas through this. So I came to the KIPS apparatus for passing H2S gas. So I am passing H2S gas. Slowly turn the knob on. You see beautifully H2S gas is being passed. You can see the precipitation also. H2S gas is passed and then you can see the precipitation. Don't forget to turn off the knob. Very important, right? So after passing H2S gas, I got a precipitate, which implies fourth group cations are present in this. I need to centrifuge this now to get the residue in which fourth group cations are present. Now I am going to insert the test tubes into the opposite holders of the hand centrifuge machine as shown here. Okay, slowly you start centrifuging. Accelerate it now. So centrifuging is almost complete. Let me check whether the residue got separated or not. See how beautifully the residue got separated. So this is the residue and the centrifugate, in this case we are discarding, but it should be tested for fifth group actually. Okay, So let's do that now. This residue contains 4th group cations, therefore it must be tested for that, and centrifugate is to be decanted, and it is discarded in this case in the present situation, but we have to actually perform 5th group cations with that centrifugate. Okay, now I am decanting to separate the centrifugate from the residue. Okay, slowly I have decanted the centrifugate. So this is the 4th group residue that should be tested for the presence of Zn plus 2 or nickel plus 2 or Mn plus 2. Okay, fine. So this is the residue that I have obtained after adding 4th group reagent to the original solution that is supplied to me by the lab attendant for 4th group analysis. So if you observe this precipitate carefully, it is somewhat grayish in color, blackish in color. So it may be containing more than 1 cations. That is my observation by looking at the precipitate as of now. So let us check what are the actual cations present in this precipitate. Okay. To this residue, I have to add little amount of dilute hydrochloric acid. So I have taken dilute hydrochloric acid and I am adding it to the residue obtained for 4th group cations. I am adding little amount of dilute hydrochloric acid. After adding dilute HCl to the residue, I need to heat this mixture. I am heating. So while heating, you must take utmost care that you need to always project the test tube towards the sink, number 1. Number 2, don't heat continuously. It should be an on and off type of heating such that the contents do not spill on your neighbors. So to the 4th group residue, I have added few drops of dilute HCl and then I heated that particular solution for 1 to 2 minutes. Now I am centrifuging. See, I am putting in the opposite holders of the centrifuge machine. Now I am centrifuging the mixture. So for change sake, we are using hand centrifuge machine. The centrifuging is complete. Let us see the residue that we have obtained. Yeah. So this is the residue I have obtained. See, you can see this residue against a white background. So this residue which is black in color indicates the presence of cobalt or nickel. But as per the APTE syllabus, we don't have cobalt. Therefore, this black residue is indicating the presence of nickel plus 2. Now the centrifugate contains other cations of this group, namely Mn plus 2 and Zn plus 2. Let us proceed. Now I am separating the residue from the centrifugate. I told you residue contains cobalt plus 2 and nickel plus 2, whereas centrifugate contains manganese and zinc. Okay, fine. Now this is the residue I obtained. Now to this residue, I must add few drops of aqua regia. So this is aqua regia. I am adding few drops of aqua regia to the residue. Few drops of aqua regia. Don't add too much, few drops are sufficient. So I have added aqua regia to the residue and then now I am heating this. Slowly heat until the total precipitate got dissolved. You heat it. You heat such that the total solution is evaporated. That is also called as evaporated to dryness. You have to heat it till the total precipitate is dissolved. Not only that, it is heated to dryness. Okay, fine. Now this is to be cooled. After cooling, this is to be dissolved in minimum amount of water. I am adding little amount of distilled water. Okay, that's it. Now this is to be divided into two parts and it should be tested for the presence of nickel and cobalt ions. But I told you cobalt is not present in our APT syllabus, therefore it is not given. So this is to be tested for nickel plus 2. I am going to do a test for nickel plus 2 using DMG, dimethyl glyoxide. What is that I am going to do? Small quantity of this particular solution into another test tube. Okay. To that add few drops of dimethyl glyoxide. So this is dimethyl glyoxide. I am adding few drops of dimethyl glyoxide. Carefully observe. We must get a scarlet red color precipitate. See, I got a scarlet red color precipitate. So this is indicating the presence of nickel plus 2 ions. If I add ammonia little amount, the precipitate gets intensified. You see the precipitate is getting intensified by the addition of ammonia. So this is a scarlet red color precipitate obtained for nickel plus 2 ion. Okay, that's it. This is the centrifugate I obtained after adding fourth group reagent to the given solution. I got a precipitate. I separated the residue. I have taken the centrifugate. I discarded the centrifugate. That residue is initially treated with little amount of dilute HCl. I got a residue black in color and then I got a centrifugate. That centrifugate I am taking here. Okay. So this centrifugate is to be heated for expelling H2S gas. So I am heating this centrifugate for expelling H2S gas. I am heating slowly to expel H2S gas. See the bubbles? You can see the escape of H2S gas. H2S gas is, you can see even the clear solution that is formed. You see, H2S gas is expelled out. Now I am adding few drops of sodium hydroxide to this. See, very few drops. I have added sodium hydroxide few drops and then again I am boiling. So I boiled after adding sodium hydroxide for 1 to 2 minutes. Now I have to centrifuge this. If I get a precipitate, okay, or residue, that is indicating the presence of Mn plus 2. Okay, let us see whether there is Mn plus 2 in this. Let's go for centrifuge machine. I am setting into opposite holders of the hand centrifuge machine. I started centrifugation. Yeah, I got a beautiful residue here and also a centrifugate. Okay, centrifugation is complete. Let's go. So I got a precipitate. This precipitate is indicating the presence of Mn plus 2 and this centrifugate is to be tested for basically Zn plus 2. So I am separating the centrifugate from the residue. Okay, fine. I have separated. This is to be tested for Zn plus 2. This is to be tested for Mn plus 2. Okay, let us see how we are going to test. To the residue, I am adding few drops of concentrated nitric acid. You see, I am taking concentrated nitric acid. I am adding few drops of concentrated nitric acid to the residue. I have added few drops of concentrated nitric acid. Then to this I am also adding as lead peroxide. Small quantity I am adding. So I have added lead peroxide or lead dioxide along with few drops of concentrated nitric acid. Now I am heating this. Gently heat. Very important. You need to heat it strongly. Now add little amount of distilled water to this. Okay. Now you observe the color of the soapponent liquid. If the color is pale pink in color, then Mn+2 is confirmed. So for that, let us centrifuge this and see the color of the soapponent liquid. Okay. Now you observe the color of the soapponent liquid. This color, light pale pink in color, is confirming the presence of Mn+2. Okay, right. The centrifugate must be tested for the presence of zinc. For that, I am taking this centrifugate and making it into two parts. This is the first part, that is the second part. To the first part, I have to add H2S gas. Then I must get a white precipitate. It is indicating the presence of zinc sulfide. Okay. It is confirming the presence of Zn+. Now I am passing H2S gas, you see. Slowly I am passing. H2S gas is passed and you can see a beautiful white precipitate formed. You see that? A white precipitate is formed, indicating the presence of zinc+2. This is zinc sulfide. For the second part of the centrifugate to test for Zn+2 ion, I am adding little amount of dilute acetic acid. I am adding little amount of dilute acetic acid. Then I am adding potassium ferrocyanide solution to this. So this is potassium ferrocyanide solution. I am adding few drops of potassium ferrocyanide solution to this. I must get a precipitate white in color. I am getting a beautiful white precipitate which is indicating the presence of Zn+2. Okay, so zinc+2 is confirmed. This is how we are supposed to do the fourth group separation table. This is how we are supposed to do the fourth group cation separation.